Hello and welcome everybody to Udacity Robotics Q&A. I'm Mike Salem and I'm here with CEO and co-founder of 3D Robotics, Chris Anderson. Chris, how are you?
Good to be here.
Great. So can you tell me a little bit about 3D Robotics, how you guys got started?
Yeah, so this may disqualify me entirely, but we actually go by 3DR now.
Okay.
And you may ask, why did we drop the word robotics? And the answer is because they work now. So we have actually been at this for about 10 years. And it started, I was the editor of Wired, and I have a lot of kids, and was just trying to get them interested in something, robotics, and failed with Lego Mindstorms, and ended up trying to convince them that flying robots were a thing. And they were unconvinced, but I was. And started a community called DIY Drones, and then that created a big robotics community, still one of the biggest, and big open source software stack. And then we turned that into a company, 3D Robotics then, which made the hardware so that people could use this software stack. And then over time, we got them working. And the drones, here's one, and drones became a solved problem. And then the next question is, well, what are they good for? How do we use the drone data for something useful in the world? And around last year, the FAA allowed commercial use without a pilot's license, and that was our opportunity to shift entirely to the software and data side. And we use drones in construction. So Autodesk is one of our investors, and so we use these things to scan construction sites and integrate with CAD, and we can talk more about it. But yeah, so at this point, our customers don't want to buy a robot. They want to buy a drone scan.
Sure.
And it's essentially a button that they push and it just works, or iPad app they swipe. And so robot and drone is bright and shiny and gets you in the door in the early days, but when you actually work, you don't want to use the word robot because it's intimidating.
Right. I think there's a similar connotation around drone as well, too,
Yeah.
right? So I started my career off 2008 doing ground control stations for UAVs, so unmanned aerial vehicles, right? So one of the things we were always specifically told was do not use the word drone. Actually.
Right. I had lots of fights with people about that initially. So initially, when we use the word drone, it's just I used to be in the media business, and there's this guy Marshall McLuhan who had this theory of media, and there's this phrase like hot words. Hot words may have positive or negative connotations, but they're attention getting. And drone was a hot word. And initially, when you were in the military, I was, an amateur, just sticking it together.
Just for clarification, I was a government contractor.
Oh, government contractor.
Not in the military.
So not in the military.
Folks out there.
Government contract, but you were using, kind of aerospace quality stuff, and drones were then associated with weapons, and and the military. And everyone said, don't use the word drone because you're only going to inhibit the commercial, recreational, consumer use of this. And I'm like, but it's a hot word. So I called the site DIY Drones, and everyone moaned about it, but it kept coming. And now, when people tell us not to use the word drone, it's because they think it sounds like a toy. So we have literally gone from the CIA to Costco in less than 10 years.
So talk about a little bit about when you first started with this, because I remember when I started with it, ROS wasn't a very publicly, widely available thing. You have different ways of doing your communication back then. You have different standards.
Yeah.
What were some of the biggest hurdles that you kind of saw when you first started this off back then?
Well, if we'd known about all the hurdles, we wouldn't have done it. But so the way I got started was I have these 5 kids, and I'm like, okay, we're going to do robots. So I get this Lego Mindstorms robotics kit, and then it's like if that didn't work, we had this radio control airplane, and we were going to do that. And so I learned this terrible lesson probably about my kids, but maybe a general lesson about kids, which is that robots are kind of boring. Real robots that you actually have to program. And so they spend all morning programming the Lego Mindstorms robotic, and it kind of moves slowly towards the wall and then bounces back. And they're like, come on. I've seen Transformers. Where are the freaking lasers? Hollywood has ruined robotics for kids. Because how do you compete with CG? And like, okay, cool, we'll just go to the park, we'll fly the plane, and of course I flew it right into a tree, and then that sucked. So I'm like, how could that have gone better? What would have been a cooler robot and a better flying plane? And I thought, well, what if the robot flew the plane? And I literally Googled flying robot, and if you Google flying robot, it's a drone. It turns out that's what a drone is. It's a flying robot. And it's like, awesome, drone, wait, what's a drone? So Google drone. It turns out it's an airplane with an autopilot. I'm like, oh yeah, of course, autopilot. Wait, what's an autopilot? Google autopilot. It's like something about sensors and computers, and it's like, okay, sensors and computers, that sounds like Lego Mindstorms. It comes with compass and accelerometer and gyros, and it's got a computer. And I was like, yeah, how do you put the sensors and computers together? And you Google, and it's like math. I was like, okay, it's probably time to stop right here.
But in fairness, you also have a technical background.
I did, but the kids,
Sure.
once we saw Kalman filter, I think the kids were like, let's just do it. So we did it, and it kind of almost worked, and then the kids lost interest, and I was like, I started this community to sort of say, what the heck is going on? If a guy and his kids can build a kind of a GPS-guided autonomous drone on the dining room table, which, by the way, according to export control regulations, we did weaponize Lego at that very moment by putting it on the internet. So if a guy and his kids can like make an autonomous drone out of toy parts, what is going on here? Something in this world has changed. So I started this community, DIY Drones, to find out. And everyone was sort of perceiving the same thing. 2007 was the year that, that it was like, some people had a Wii controller for the, the video game Rock, what's in here? And those guys are like accelerometer, and they turned into Fitbit. And other people were, were playing around with 3D printers, and the maker movement was just starting. And basically the answer is the iPhone. That's the year the iPhone came out, and those sensors became available. So, it's like, okay, you can buy MEMS sensors and good cameras and GPS and wireless, et cetera. How do you put it together? And none of us are really expert on the interdisciplinary skills needed for robotics. So we just started doing it. And the first thing we did is we went with the open source hardware platform of the day, which was Arduino. Mm-hmm. So we like, okay, Arduino can talk to sensors, and we know how to program an Arduino. So let's just make an Arduino powered drone. We called it ArduPilot, and it was like a little board that cost $24. And I went to the big industry conference. This was AUVSI, which is the Industry Trade Association. It was like all military.
Yeah, definitely.
And it was like, and some guy invited me in to be the keynote for reasons that he probably regretted. And it was like General 1, General 2, General 3. These guys have like,
Oh yeah, totally. Yeah,
I've been to
those places.
Yeah, they're actually generals talking about the future of aviation. And then this dude comes up with this like board that costs $24 and say, open source, drones are the future of aviation, and you can buy an autopilot for $24 and stick in a radio control plane and do what these guys are doing. And they just, they couldn't decide whether that was crazy or dangerous or both. But the reality is we couldn't really do what we said at the time because, as we were able to get the airplanes working, that was fine. But when we moved to the copters, to the quadcopters, nothing worked. And we realized that the thing about airplanes is they kind of want to fly, and copters really don't want to fly. And our code was just super lame. Like it was crashing. It was actually rebooting in the air because of race conditions or whatever. And we didn't know, because when an airplane autopilot reboots, it just keeps flying. And when a copter autopilot reboots, it tumbles to the ground. So we basically, by starting with airplanes, we kind of got away with murder, and were able to kind of get something that looked like it worked and kind of vaguely navigated with GPS. And then by the time we turned to copters about 2 or 3 years later, and everything broke, we at least had enough confidence to think that maybe we can fix this, to kind of come back to to first principles and understand things like Kalman filters and and real-time operating systems and testing and all that kind of stuff. So it was hard, and there were some dark days in the copter when we didn't have proper simulators and didn't have proper test environments. Remember, it's open source, which means that people would take the boards and then stick them in random vehicles and like solder badly and connect things badly. Sure. And do things upside down and backwards, and so the number of variables that could go wrong was essentially unbounded. And we didn't have a kind of a framework to be even, people would say, you suck because my drone crashed. And we're like, they might be right, we might suck. But we don't know, and until we had the ability to data log the whole thing and auto-tune them and all this kind of stuff, there was moments where we weren't sure whether they sucked or we sucked. And it turned out that it was mostly them being the users.
Right.
And we did suck, but we didn't suck as badly as they thought, and we eventually stopped sucking.
Now, when you're talking about flying these, you're talking about going from basically a small scale plane into a copter, right? Was there any communication that you had with it once you launched it into the air?
Yeah. We have ground stations.
Sure.
The idea was drones, in our mind, are autonomous.
Sure.
Now, the word autonomy is obviously here one must not use the word autonomy loosely, but in our mind, it was basically GPS guided. So automatic takeoff, automatic mission, automatic landing. No touchy. We do have ground stations. The ground stations were largely to monitor. Initially, they were just to monitor the data as it came in. But you could dynamically change the mission. So in your ground stations, probably in your contractor days, you would do things like you would click on something and like loiter here or go there or look at that. Right? Are those typical? Or
those are typical things.
You would have to kill me if you to tell me the. Anyway, those kind of higher level mission commands were what we were doing. We just had a radio link. Initially it was like things like XBs. Later on, we built our own radios. Then, as years went on, video became more of a thing, and digital video became more a thing. And today, a ground station is largely a lens. It's largely your visualization, your viewfinder, if you will, on what is largely a flying camera. And in our case, we do have ground stations, but it's really just for FAA compliance. Sure. Which is the FAA wants a pilot in command, which is funny because there is no pilot and they're not in command.
Right.
But they're there, and if there was a reason, like some emergency services helicopter would come in here, they can pull up their tablet and press a button and say, come home, and that's what it's boiled down to.
Yeah, so I know one of the big things that we used to work with is actually line of sight communication. So that's always a big thing when you have a ground control station and you have a vehicle flying in the air, you want to make sure that you have communication with that vehicle at all times.
Yeah, which is defined by the FAA as visual line of sight, which is, we love the FAA. They're actually being really helpful right now. But it is crazy because visual line of sight is never defined. Mm-hmm. Visual line of sight could be that tiny black dot a mile in the distance. You can see it, but do you know the orientation? Can you really see how far it is? Can you see what's around it? Whereas, the FAA defined it as unassisted visual line of sight. And you and I both know these things are bristling with cameras. If you would let me go assisted, in other words, look at what the drone can see, I do a much better job of taking over control, but it's not allowed.
Yeah, definitely. So going from the small-scaled planes to basically copters, right? One of the interesting things that you're mentioning here actually is that a lot of your code broke, the reboots, right?
Yeah,
Things would just kind of tumble out of the skies. But now you see these types of drones pretty much everywhere, right? This is like the preferred method, it seems like, for consumer drones. Why do you think that is the case? You think it's because they're able to loiter and stabilize better, or the movement is more controlled?
The reason that copters have won, and fixed wing, which I love, is pretty much gone at this point, is because basically about landing. You want drones to be able to kind of fit into any environment. So your backyard, the street, a construction site, whatever, which means they essentially have to be vertical takeoff and landing. Mm-hmm. The problem with fixed wing is physics, which is that they only fly when they're moving forward, which means that you need some area to land. And we spent so many years trying to kind of perfect vertical takeoff and landing, and maybe it'll happen. But basically, fixed wing needs to sort of be moving forward. You can have it spiral down, but it still needs to be moving forward. Typically, it needs to be moving into the wind, and so it needs at least 10 meters. And then you've got trees, and so it can't just can't go zink and land. It kind of has to come down and land, and these things are always getting caught in trees. And it's like parachutes. That's just another thing to get caught in trees. So now it's like vertical takeoff and landing, which is great, except for the problem with airplanes. They have wings, which means they're essentially catching the wind and sails. And so vertical takeoff and landing works great until it's windy, and then it's just back in the tree.
Yeah, definitely. I can't tell you how many vehicles I've heard from the small UAVs, like these planes, that have crashed and burned on the way down, and you're talking anywhere from $30,000 to a couple $1 million.
Yeah.
It's not exactly the best way to go.
No, it's not. So basically, the reason copters work, the reason copters are taken over, is that they are the easiest thing to do. They literally are. You push a button and they do it. You don't have to think about wind. You don't have to think about throwing. You don't have to think about landing. They turn a drone into something that can be autonomous in any situation with no skills.
Right. So I know you've pivoted your company slightly, right? Going from manufacturing to actually utilization, right? Can you tell me a little bit about some of the utilization you have right now for your drones?
Yeah. So the plan was always to do this, he says only slightly defensively. The plan was always there's going to be three phases of the industry. Phase one was the technology. Let's just get the robots to fly. And this is the autopilots and the sensors and the comm stack and the control, then the ground control systems and all that. And that took us like 5 years or even longer. Not as a company. The company's only 4 years old, but as a community. That was hard. Okay, then the next phase was, okay, now that they work, let's make them easy to use. And that means turn them into a consumer electronics product, which you could just open the box under the Christmas tree and press go. And it turns out the skills necessary to get robots to fly bear almost no resemblance to the skills necessary to make a computer electronics product. Those are all about manufacturing, supply chain, distribution, retail, customer support, all that kind of stuff. And then the third phase was always going to be, okay, there's tech, then there's toy, then tool. For alliterative sake, they have to have T's.
Right.
And tool is going to be like, let's put them to work. Let's put sensors in the sky, because really, why are we doing this? And the answer is to measure the planet. You got satellites up there, you got Internet of Things down here, and this is like the Internet of Flying Things. It was going to be, sensors in the sky so we could measure the planet, so we could manage it. And that was always the plan. And we always knew that we were going to be there. The question is, we weren't sure what part of the planet we were going to measure. Is it agriculture? Is it going to be scientific sensing? And we actually thought it was going to be agriculture initially, because it makes so much sense, right? It's a huge industry, very hard to measure, chemicals and water, and there's a lot of inefficiencies. Turns out agriculture is really fragmented. A lot of the inefficiencies in agriculture are insulated from the farmer because of things like insurance and crop subsidies. And so we were kind of fiddling around a little bit with like inspection and cell phone towers and things like that. And then a friend of mine in Berkeley, named Carl Bass, who was the CEO of Autodesk, he and I played tennis every weekend. And and they were Autodesk essentially owns the construction industry. All the CAD software that's used to design buildings is Autodesk. And they were like, so here's the thing with software and construction is that everything's digital in the design, but then the moment you dig a spade of earth, it's analog. And you've lost the ability to measure. Now it's paper, and the life cycle is ended. So we need to re-digitize the construction site so that you can continue to manage it with the same tools used to design it. It's called building information modeling. And they were like, well, okay, it makes perfect sense. It's called reality capture. So how are we going to do reality capture? And so they were thinking, well, LiDAR. And LiDAR on the inside works great, but it's kind of hard to scan a whole site in LiDAR. And then we're like, maybe photogrammetry, click, click, click on the ground. But again, it's the wrong perspective. And so it became clear as we talked that we were the capture, the drones were the capture in reality capture. That the way the construction industry is the second biggest in the world, the average commercial project is 80% cost overrun. So it's an $8 trillion industry that really should be like a $5 trillion industry, except for the $3 trillion worth of inefficiency, and they're not insulated. Like when a project runs over cost, somebody pays. Mm-hmm. Most of these projects end up in a lawsuit because of mistakes. Something happened between as designed and as built. So it was just the parallel paths of Autodesk and drones that allowed us to sort of recognize that construction was the right industry for us to measure. And that was the right industry for us to manage, and that this big macro trend in construction to go digital was the macro trend that these would be part of.
It's great. I know you talked a little bit about this transition that you went from tech to toy to tool. What's it like kind of ramping up a manufacturing process and kind of putting these things at a large scale? So this is something I know a lot of folks out there are really interested in. Like, there's like, oh, I'm going to build a company, and then from this company, we're going to sell millions of units. But there's this huge piece of the puzzle that really kind of goes until the very last step, and then it circles back around, and you're like, wow, I didn't realize how much work this was going to be.
This is like the curse of Kickstarter. Like, I think I've decided like the very worst amount of money you can raise on Kickstarter is $1 million, somewhere between $1 million and $10 million. Because if you raise like $50,000, you know how to make 3,000 boards, right? It's your same sort of like hacker mentality. You raise $100 million, and you can hire professionals to do this. You may raise like $1 million, and now you're in you've created real expectations, real volumes. You have to switch from your kind of DIY practices to like contract manufacturing with supply chain, all this kind of stuff, and you've got none of the skills. So the problem actually is kind of interesting on those three levels. The skills that can allow you to win in tech are not the skills that will allow you to win in toy, which are also not the skills that allow you to win in tool. And I would say we won in tech at 3DR.
Sure.
We're going to win in tool, and we got our asses kicked in toy because we were up against a company called DJI, which is based in Shenzhen. And they basically, now that company hadn't, but all the people they hired had been making iPhones for the last 10 years and taking notes the whole time. And the notion of supply chain management and efficient distribution and all those skills that are kind of just in the water in Shenzhen are hard to learn. You think, oh, well, I'll just go contract manufacturing. When you're up against a company as good as DJI, moving as quickly as that, it's not fast enough. And it's so we did really good. We hired a great team. We had great contract manufacturers. We worked with PCH, et cetera. And we came out with a product that was priced at about $1,500. This is the early consumer version of this, priced about $1,500, which was at the low end of the the sophisticated ones at the time, and had a bill of materials of about half that. 9 months later, the going price, the sales price, in the shelves of Walmart was $4.99.
Wow.
So it's 70% cost declines in 9 months, because we were up against. This is what happens. And anybody, if there's anybody takes any advice from this, it's like all you guys who are doing, robotics hardware, and you're saying, yeah, I totally get it. China's really good. I know the commodification is coming, but we have 3 to 5 years. You've got 3 to 5 months. It's happening much, much faster. We were one of the first companies to kind of go up against a true 21st century, Chinese unicorn. Right. Who did everything right? It wasn't just the innovation. Yes, they really innovate. It wasn't, and in software and in hardware, and they went global up front, and they had handled distribution and marketing and design up front, and there are countless other Chinese companies that are getting ready to do that now. So, find one. If you want to do a hardware product, find a Chinese company that's thinking about this and partner early, because they're coming.
Great. Here's some great advice. So can we talk a little bit about this drone here in particular? So is this one of the drones that you would use for your construction site?
Yeah. So this is a site scan unit, and it comes in a box. And basically, it's a standard kind of consumer grade drone, except for a couple things. First of all, it's got a really fancy camera on here. This is a Sony R10C camera, which is a custom one they made for us, but I can't remember what it's called. It's a consumer one, but basically it's all about, with cameras, it's all about the glass. I mean, It's a big sensor, but it's really about the glass. And this will at 200 feet, which is kind of a safe altitude, this will do less than 2 centimeters per pixel.
Wow.
Which is good, good enough for construction.
Definitely.
It's not doing video; it's doing still. So it's on a pointer rather than a kind of a highly. It's a stabilized gimbal, but it's not the one you use for video. But most importantly, we control it with a drone. So when we in the app, you say, I want a 3D scan of this or a 2D scan of this or an inspection or whatever. The algorithm that does all the merging of the images in the cloud, it knows what it wants. So it's like, so the algorithm might say, well, I'm going to want 50% overlap and side lap. I want, the algorithms, these do photogrammetry, which is basically extract position from the geometries of features. They actually want translation.
Can you explain what features are for some of those?
Yeah. So the way this does is it takes photos and they overlap, and so a feature could be your shoe.
Sure.
Right. And if I see your shoe from this photo and in this photo and that photo, if I just trace lines, through those, there's a foreground and a background. I could say the same feature seen from different perspectives allow me to figure out where my camera is.
Right. So they're typically unique points of interest, though.
Exactly. They're identifiable points of interest. And typically the software will find those on their own to be unique colors or shapes or things like that. And so this is called photogrammetry or reconstruction, and it finds position from line tracing through objects. So the algorithm wants, there's certain things that work better. So a certain amount of motion, a certain amount they like translation better than rotation.
Sure.
And there's certain settings. So motion blur is really bad. Certain light, contrast is good, etc. So the algorithm basically tells the camera via the drone what it wants, and then we construct a mission, which to a human eye might look really weird. Sometimes we hatch, sometimes we lawnmower, sometimes we circle, sometimes we do all of the above, and we point the camera throughout for the flight patterns, exactly. And we point the camera throughout. And all of this is because we're talking to the algorithm and know sometimes in real time, sometimes ahead of time, what the algorithm is going to want from this particular image. And then we control the camera settings, the shutter speed and the aperture settings and all this accordingly. So that's why you want kind of a smart system. because ultimately it's going to the cloud, and it's about the data quality that's going to produce the mesh you want.
Yeah, and that stitching process is actually very computationally expensive, right?
It is, yeah, which is why we do it in the cloud.
Yeah, definitely.
It's still 2 hours.
How long are, I don't know if you can say this or not, but how large are your images typically in terms of size?
20 megapixels.
So yeah, you got some really fine-grained granularity that you're stitching back together when you're laying these mosaics.
Exactly. So we typically send somewhere between 200 and 300 photos to the cloud at that resolution, and you end up with what's either called an orthorectified 2D image, which is basically as if the camera was always looking straight up and down. And the reason you care about that is when you look straight up and down, all the 90-degree angles are 90 degrees, no distortion. Right. You can also get a mesh, which is basically a 3D model where it's all polygons, or you can get a point cloud. And the interesting thing about point clouds is that's the same data that a laser scanner would give you. And so then you can combine your laser data on the inside and from the ground with your photogrammetry data, and it all sort of is on the same orientation coordinate plane. Would
you mind taking just a little bit further of a dive into the point cloud mapping and kind of explaining that method a little bit? It's one of the methods actually our students are going to learn in the Nanodegree program.
Yeah, so...
I'm sorry, just to interject, they're going to do it with an RGBD type of image though too, but just from a pure camera perspective image.
Okay. Well, so the easiest way to think about a point cloud is with a laser scanner, which is to say that that a laser is pulsing at a certain rate and traveling at a certain rate, and so basically each one of those pulse angle switch is it bounces off something, and that something it bounces off is a point, and it's in 3D space. And you can decide to connect the points with polygons, and you can get shapes. Now, what a camera does is essentially the same thing, but it does it all in software. So now you have a feature which is seen from two orientations, and where the rays intersect is the point. And the interesting thing about a camera is that you also have a texture map. So although you can take the points and build a polygon, a mesh around it, now you have the textures from the actual photos themselves, which you can now project onto the mesh, and now you have a beautiful 3D model that looks photorealistic.
Perfect, great. That was a great explanation. Thank you for that. So talking a little bit about the construction site a little bit more. So right now you're doing this to kind of do reconstruction of 3D scenes. Is there anything else that you would like to see?
Actually, I thought, because in the demos we always show like 3D model, scanning 3D model, it's photorealistic, and the construction guys are like, couldn't care less. We live in a 2D world. Right, so if you go to a construction site, it's paper. They print out these layers. It's all 2D, and we're like, oh, okay. So what you really want is an ortho, the orthographic, projection. And so what we end up doing mostly is there's 3 phases of the site. There's where it's a barren site, and it's about dirt and topologies, and you want to characterize the site. You want to know exactly its elevation. And we do something called a digital elevation map that comes out of this. You want to, if there's a hole, you want to know how big the hole is. If there's a hill that you need to take down, you want to know how big, because you're moving dirt in or you're moving dirt out. You want to be able to place it in the exactly in the right coordinate system. By the way, a little aside. This is one of the things I learned. So you would probably think that the coordinate system of the world is latitude and longitude, not the construction world. The construction world has local coordinate systems, and the way to think about this is when we're in America, and America was uncharted territory, and people came out, and these were surveyors, and they wanted to sort of like draw lines for states and cities and property lines and things like that, and they would like cite the stars, and a surveyor would stick it on a stone post, and that stone post is 0, 0. In that coordinate system. Okay. And then the next guy would come along with a telescope, and they would sight off the stone post, and that would be, 1640, there'd be like 1632 on that coordinate system until you get about 5 telescope lengths away, all line of sight. And at that point, you're like, yeah, our air bars are starting to build up a little bit. It's time to put down another stone post, and that's another coordinate system. So you probably think we're here at lat long something, right? But if you ask your landlord about the property line, they'll tell you where you are in the, what town are we in, Mountain View? Yep. You're in the Mountain View East, 2 coordinate system. And it really matters because when you go to the county office and say, this is where I want to do, they're going to pull up the records of like where the property line is, and they're all in these local coordinate systems. So that's one of the things that, we got away with murder in GPS. In the real world, you have to speak their language.
Wow, that's a really interesting thing. So I know for the flight patterns that we used to do, it was all GPS based. So jumping into that coordinate system must be a little bit of a challenge.
Well, the hard thing is that we were taking pretty pictures and like, hey, pretty picture, and they're like, yeah, that does me no good. Here's my world. My world is paper CAD files with layers that have coordinate systems, and if your data doesn't speak my language, is not meaningful to me. So we had to first georeference it onto their coordinate system. Then we had to what's called rubber sheet it, which means we have to dimensionalize it in both directions so that everything lines up. And we have to do that with these things called ground control points. And they basically take an RTK GPS, which is a super high precision GPS, and they put like these lines, these little dots here. And you go around and you stick a couple like known points on the site that are really accurate. Then you stick like an orange post on it, or like a big like a pie plate or something like that. And what our software does is it spots the ground control points and then dimensionalizes the data to match with that.
Wow, it's really cool. It's a really advanced way of kind of
the real world is messy.
So a couple more questions I have for you around this topic is if I wanted to come and work at a company like 3DR, what kind of skills would I need?
Well, in the early days, our skills were, so the software that we were building was all open source. And today we've moved it, all of that into the Linux Foundation. It's called Drone Code, and I'm the chairman. I started it and chairman of that. And so all of that early work is now a very sophisticated full stack that's all BSD licensed, and it's everything from the low-level sensor through the autopilot, through the comm stack, the ground stations, and even the cloud and regulatory compliance and all that. So if you want to do kind of like robot software, that's now in the community. You're very welcome to contribute, but that's not the company. Then the next phase was the boards, the electronics, and that was a lot of what started with simple stuff like Arduino. Again, we got away with murder in those early days. 2-layer boards, 16 megahertz. I mean, it was you could lay it out and do it yourself. Now they basically look like smartphones, and so typically the autopilots will be like a Qualcomm or an Intel one, and they BGA. Chips, and it's pretty hard stuff. So electronics is kind of like kind of use smartphone stuff as best you can, or Raspberry Pis or things like that. Then you got into the consumer electronics side, and that was all mechanical. How do you come up with the composites and the design that minimizes weight, maximizes flight time? Noise is one of the problems with drones, and so really it's a slightly there's a lot of solved problems with drones today, but one of the unsolved problems is that they're still a little bit noisy, definitely, and annoying, and the pitch is like right on that kind of like grating in the ears thing, and that's a combination of speed, the speed it turns, the design of the propeller, the turbulent interaction between the propeller and the body, and then resonant frequencies and nodes within the body. And to run this, so we run this through a lot of simulators. We run it through mechanical simulators, cost simulators, strength simulators, but you also want to run it through an acoustic simulator to try to minimize that. So on the consumer electronics side, mechanical is still a thing. But on our side now, where we are today, when you look at our team, we do front-end web, which is the tools on our web manager that people use. There's back-end web, which is doing some of the machine learning and integration of drone data and photogrammetry data. And then we have iOS apps or mobile apps, which are not super hard, but from a kind of UI perspective, but need to sort of speak drone language as well. So I would say that basically think of drones as having entered their data era, and it's less about the robot and more about the data, which means that machine learning, neural network, computer vision, big data analysis, ability to possibly identify features and project them. Those are the skills we need now.
Data engineering, I would imagine, too, for managing pipelines of this data.
We're lucky in that we work closely with Autodesk, and they handle a lot of that.
That's nice.
But yeah,
that's a big problem for a lot of folks out there.
Yeah, it is. And one of the things that this is an example of cloud robotics. And I don't know, have you talked much about cloud robotics?
We've actually done survey papers in our research group in our Slack community on cloud robotics?
So the beauty of cloud robotics is that you have the robot and you have the cloud, and you can kind of use them both as appropriate. Which is to say, that maybe you sort of push the computational function upstream into the cloud, and to allow the robot to be smarter. Theoretically, we do that. In practice, in the real world, our communication links are pretty, I think, non-deterministic is the nicest way to say it.
Sure.
Which is sometimes they're good, sometimes they're bad, and sometimes they don't exist at all. Yes. And so, an interesting question is, like I described a scenario by which we dynamically adjust the mission. So in your world, back in your old days, you probably defined a mission, and then the mission determined the data. But in a perfect world, you'd define the data. You'd say, this is the data I want, and it would just figure out what the mission is to get that data.
Right.
So the data would determine the mission, and the drone would just go to wherever the data was needed and would figure it out. That loop closure, that sort of dynamic mission planning, which uses the algorithms, steering the drone, if you will. That's a perfect example of cloud robotics, and we haven't figured out exactly how to reliably do that with the comms links we have. So that's a systems architecture problem that we haven't solved.
Well, it's nice to know there's some things in the field that can always be improved upon, right?
Indeed.
So one last question for you on this topic is,
okay.
Is 3DR hiring?
We're hiring back-end engineers, back-end web developers. I have to say that in fair warning, we do use Scala.
Okay.
In some of our back-end systems, not all of them. I know there are reasons for it.
Sure.
We're not wedded to it, but if you happen to know Scala, that's great. And we're hiring iOS developers as well.
Perfect. So let's go ahead and take some questions from the audience, if you don't mind.
And can we talk about cars at some point too?
Absolutely. So you want to go ahead and talk about it now? We can do that really quickly.
Really quickly before we take questions.
Absolutely.
So the story I just told you was 10 years ago, DIY drones, community turns into a company turns into a business. We don't do drones anymore because we did them. We're starting it all over again. We're doing it with cars, so DIY robo-cars. And so what we have here is, cars are interestingly harder than drones. They're harder than drones for a couple of reasons. They fly in they operate in crowded environments. Sure. They don't always have GPS. So it's about computer vision and LiDAR and things. So we get away with murder because we have GPS. And because we can kind of, we can fly like in a big open sky.
There's not a whole lot to run into either when you're up in the sky.
Exactly. These things don't have that. And so when I, as the nerd, not the CEO, when I, as the nerd, went looking for the next hard problem, it became clear that cars are right where drones were 10 years ago, which is to say that the core technologies of LiDAR and computer vision and open source software are now easy enough for a regular person to use. But I don't have one. I didn't have a drone in 2007. You had a drone, but I didn't have a drone because they cost $10 million. Now I don't have an autonomous car because I don't have one, because I don't have a Tesla. My wife won't let me buy a Tesla, and she won't let me hack the family SUV. So what am I going to do, right? I could take the Udacity course and do it in simulation, but frankly, I want to get my hands dirty.
Sure.
So we decided to put the letters DIY in front of autonomous cars and basically take the Udacity self-driving car stack and implement it at less than $250. So this ridiculous thing is basically everything you would find in a Tesla or Google car, but not as good. But you can have one of these. We have instructions on the site. It's basically $250 worth of stuff you buy on Amazon. And LiDAR right now is 2D scanning. LiDAR costs less than $200. We use Raspberry Pis because, because you can run TensorFlow on them. They run computer vision. They're connected to the AWS cloud.
Sure.
And we race them wheel to wheel in a big warehouse in Oakland every month. The next one's on June 17th. And right now, I run the computer vision team. And there's other guys who run the neural network team, the TensorFlow team. And right now, the neural network team is a little ahead, which shall not last. But we think of this as being like the Tesla approach, which is kind of a computer vision approach, versus the Google Waymo approach, which is like a neural network approach. Sure. So it's like Tesla versus Google, wheel to wheel at like 30 miles an hour. This one doesn't go 30, but the others do. In a crazy Oakland warehouse, may the best code win.
Definitely, and if you're in the Oakland area, people should come and check that out. Make sure
so we also have them. We have meetups that do this in Washington D.C., in New York, and Austin, Texas, and we're looking for more. So go to DIYrobocars.com and see you on the 19th, 17th.
Awesome, sounds great. let's go ahead and shift to a couple questions from the community. I'm sure a lot of folks are eager to talk to you. So we have some questions here from Adam. Hi, Chris. Thanks for taking our questions. I know you made a mid-career transition from journalist to entrepreneur. Can you speak about your experience going from tech journalist to tech CEO? Also, can you provide any guidance for those of us who are thinking of going from employee to entrepreneur mid-career to consider? Thanks again.
Totally. Yeah, good question. So my career looks super random, it is a little random, but actually I was trained as a computational physicist, and and unfortunately physics kind of cratered because we didn't have we couldn't afford particle accelerators anymore. So I had to go off and do other stuff. And this actually is computational physics. So sort of physics to drone makes perfect sense. The weird thing is like the whole media thing in between, and it was basically just I went from doing physics to working for the big scientific journal, Science and Nature, and then The Economist, again doing sort of science and technology, and then Wired, and then ran Wired because it was sort of telling the story of all this, and what seemed like the most exciting story of the day. A little bit of clarification: I was actually the editor of Wired, not a journalist, and so I was running a company called a magazine, but it was about 120 people. And today I run a company of about the same size. So going from editor to CEO is really quite straightforward.
Sure.
There the product was a magazine. Here the product is a drone or software. But it's the same kind of cycles. We had monthly sprints, milestones, and and pipelines, and that was actually quite similar. To go from writer, I was also writing books like The Long Tail and Free and Makers, etc. To go from writer to entrepreneur is a little less obvious. I would say the only key connection there is that communicating what you're doing clearly is a good asset in any discipline. It's good for your team. It's good. It's a way to get investors. And so when you think about writing as a way to essentially market an idea, that's a great skill for anybody. So that was the first question. The second question was about from
transitioning from mid-career, from employee
into entrepreneur.
Right.
This is actually my 5th company, but it's the first one I did full time. My other companies, I had so many crazy companies. I had a company that did mobile gaming in 2009 before there was any mobile, which was a good idea, but it's all about timing. Transitioning to running my own company, that was actually not that hard, because what we did is we started the company as a side project. And so by the time we raised venture capital and I left Wired and took over as CEO, the company was already $5 million of revenues, already had about 70 employees, was being run by my co-founder, Jordi Munoz, and it's a terrific story. Basically a Tijuana teenager I met on the internet, who turned out to be absolutely brilliant. So we de-risked it entirely. And so I would encourage people to not quit their job and start a company, but rather get a hobby, turn that hobby into a kind of a side project. Try to kind of take it as far as you can, to de-risk it. Is there something there? And the moment there's something there, then dive in with both feet. I mean, focus is super important, but you don't have to you don't have to quit your job and start a company before you know there is a company there.
Right. I think that's great advice, and actually a lot of successful people actually emulate that kind of pattern.
I call this industrializing your hobbies. Yeah. A, have a hobby. B, grow your hobby as fast as you can. Obsessions are great. And at a certain point, somebody's going to say, hey, that might be a thing. That could be a company. And that's a signal.
Great. So this next question is from RP. Hi, Chris, and thanks for taking the time to do this. 3DR was built on the open source community you helped found. Your perspective on open source is well publicized, but what are some of the pitfalls you have encountered?
Yeah, so this is a tricky one, and emotionally kind of complicated as well. So I'm a big believer in open source. Everything I do, everything I have done in my career, and all this stuff is all open source. Now, at a certain point, not everything can be open source, but I believe in it strongly. I started the Archipilot project. I started several others, and today Drone Code is open source. What I learned as we scaled is that something I had paid no attention to, which is licenses, actually turns out to be really important. And so as the community grew, we grew. It was, we had to structure the projects properly. And one of the things people don't recognize about open source is that actually traditional command and control, rules apply to open source as well. You need maintainers and roles and responsibilities and meetings, and you hire and you fire. They're not paid, but
you need a vision too.
You need a vision. So you need like a benevolent dictator, and I played that role for a while. As it succeeded, and we ended up putting more than 1 million drones in the air on this platform, and it's still going very strong. We entered the commercial era. In the commercial era, we wanted big companies. So in the early days, we wanted developers to adopt them, and then hobbyists to adopt it, and that worked great. But when it was time for big companies to adopt this software, suddenly we had to get super sophisticated about licenses. And it turns out and again, with my own total acquiescence and approval, we had adopted the GPL v3, which is a copyleft license, and companies will not adopt GPL v3 code because of its viral nature. It requires all derivatives to be open sourced. And companies, A, don't like to do that themselves. Big companies don't like to do this themselves. And B, they're very worried about the GPL infecting the rest of their code bases. And so we had companies like Intel and Qualcomm who have rules about this. And the GPL was like a no-go. Fortunately, we had a second project that came out of ETH, the University in Zurich. And that project, called PX4, was BSD licensed, which is called a permissive license. And a permissive license allows you to not open source it if you don't want to. And so we ended up having to fork, having basically split the two. And PX and drone code is now based around the PX4 BSD stack. And ArgPilot is doing great, even better than it did when I was running it as a standalone under the GPL stack. But it was a divorce, and it was angry, and it made me sad because I love those guys. But it was just a learning process about how licenses matter.
Great. So what do you see as the future for drone code?
For drone code, yeah. So we're going to be releasing our next stack, version 1.6, I think on Monday. It's super good. It's the best tested we've ever had, and it is. We just relaunched the site as well, and we are now. It is now production ready, which is to say that professional grade autopilots can run on this. We're working with the FAA on regulatory compliance. It is tested at almost, I would say, I don't know whether aerospace grade is the right way to put it, but it's the best tested we've ever done. So it is, this notion of a kind of an Android equivalent. So the model was we're Android and DJI is iOS, right? Unfortunately, we don't have a Google, to be the sponsor. So instead, we have Intel and Qualcomm and a manufacturer called Unique and 3DR, et cetera. We've got it to the point where the first commercial vehicles using the drone code stack will be coming out in August of this year. So right now, if you want to use it, use a development platform like Intel Aero or Snapdragon Flight. But if you want a commercial vehicle that just runs drone code, you're going to have to wait till August, and I won't tell you who's going to release it.
Sounds good.
But that's what's coming up.
Stay tuned for that one, right?
Exactly. We are ready for prime time.
So the next one is, how problematic do you consider a single vendor dominance of the drone space to its future development?
Well, if you're going to be dominated by a single vendor, hope that they're good. And the good news is that DJI is just freaking amazing. So right now, DJI dominates the hardware side, and they dominate not because they cheated. They dominate because they just are great. They innovated. They innovated fast. They brought prices down. They brought quality up. So I for one welcome our DJI overlords. It's a little bit like the iPhone in the early days. How problematic was it that Apple dominated the iPhone for the first 5 years? Smartphones. Not problematic at all. They did a great job. At a certain point, I think there will be some concerns about that kind of dominance. The concern could be pure, what if they turn evil? What if they stop executing so well? Another is frankly, geopolitical, which is to say, as drones become more and more important, and as the data goes into the cloud, there's going to be some people who just, the U.S. government, for example, will not allow its agencies to buy DJI drones right now, because of concern that the data about where the government is flying is going to go back to China. I don't think there's any evidence that that's a concern, but you can see in this kind of fraught political environment,
Sure.
there's going to be some demand for that. And then finally, I think, and this is the most important one, I think there's going to be demand for an open stack to go along with a closed stack. Again, I'm a huge believer of open innovation, and I think right now, it goes in cycles. There was the open phase when we were just getting the technology to work. Then there was the closed phase where we needed to be, vertically integrated and really, work well. That's where we are right now. And now I think there's going to be a time for an open phase as well. And DJI has an SDK, which is good, but we have a full open. We're open at every layer with drone code, and it may be the innovation shifts down to the camera side. That's not open on the DJI side, or maybe it moves up to the cloud side. And so because we're not sure right now, we want to keep our options open with the openest possible stack.
Perfect, great. Thank you for that answer. So this next question is from Shriyak. If one does open source their product, what kind of precautions should be taken, and how do you ensure consumer loyalty?
Yeah. There's two elements, the open source hardware and open source software. We did both in the early days. I would say open source software, if you open your software, there's a lot you can read about monetizing open source. It's actually quite a good Andreessen Horowitz podcast. It goes to A16Z podcast, particularly about monetizing open source software. The answer with open source software is you typically take a service layer. And that service layer could be a user interface, it could be a management layer, it could just be an education, a packaging layer, and you monetize that. So for example, we use open source software, but we have proprietary user interfaces like our app. And our cloud services are not open source. Anything that goes in the cloud is more easily to make closed source. So I think that's relatively easy. The hardware side is harder. We were seduced by the success of Arduino to believe that open source hardware was the way to go. And I think in retrospect, we were wrong in two dimensions. First of all, hardware has gotten a lot harder. In the Arduino era was, anybody could create one of those boards and do a derivative design. Today, the boards are running at gigahertz speed.
Sure.
8-layer boards. You can open source a board, but regular people can't do anything with it. In fact, you're just enabling the cloners. What we found with open source hardware, and I think is really good for consumers, is that the Chinese love it. So today you can buy an Arduino for $1.60 each board with free shipping from China. Wow. So I was talking to Massimo Bonzi, one of the founders of the Arduino project at Maker Faire this weekend, and he's like, this is Massimo Bonzi, successful project, and we're having the same conversation we've had for 12 years, which is, how do we build a business around Arduino? They still haven't figured it out. And I haven't figured it out either for them, because the hardware is commoditized so quickly, and you're essentially enabling the cloners. Now, it's great for consumers, it's great for innovation, it's great for the world. But I can't figure out how to build a business around open source hardware, which is why we don't do that anymore.
Yeah, I get it. So this next question is actually from Lunar Pulse. This is the last question. So I am a PhD student studying autonomous drones for indoor or GPS and radio or even vision denied conditions, where human operators cannot control through radio and computer visions hardly work. How does 3D robotics go with this topic, and how do you view this in the current and future positions of the drone industry?
Yeah, so we chose not to go into that market for a couple of reasons. First of all, it's not clear there is a market there. I mean, what indoor drones, what are they for? There was absolutely going to be an answer, but I couldn't figure out what it was. The initial stuff was like reading barcodes in warehouses and things like that.
Crowd surveillance maybe, or something like that? Airports?
Indoors with drones? I mean, we have cameras.
That's true, right?
If you're inside a building,
sure,
you've got cameras everywhere. Don't take the camera there, just put cameras everywhere. So I think I'm probably wrong, a poverty of imagination, but we could never find a big market for indoor drones. Secondly, if you do want to create a local positioning system, there's lots of ways to do that doesn't involve vision. I mean, you can have ultra wideband, you can have ultrasonic, you can have light in indoor positioning systems. Thirdly, we assumed that Google was going to solve the indoor, the visual SLAM problem, and with Tango and the stuff they announced more recently, I think they probably will. So we basically said we're not sure it's a market. It's way early. All the technology solutions right now suck. There's probably some much easier ways to solve this over time, and so we just decided not to go into it. at all. And to date, there has not yet been a market for indoor drones. There are demands for GPS-denied drones outside, and it's typically the military that wants those. In our world, we have GPS. It works pretty, in construction site, almost, we're in the open sky, it almost always works. If it doesn't work, we have optical flow and visual odometry, which works well enough. We even have dead reckoning, which will work well enough. So we've never had a need for GPS denied, so for robust, long-term GPS denied solutions. And we do have VIO, visual odometry there, in case we need it. I know that grad students love this topic. There's 3 topics that grad students absolutely love that we've never found a market for. One, swarming. Swarming is the #1 robotics,
it's one of my favorite areas, but yeah.
There is, as far as I can tell, zero demand for true swarming of that sort. And so the first thing we do is, when resumes come in, they did swarming. Like, oh God, okay. Right. So onboarding, forget swarming. There's no market for it. I'm probably wrong, but that's it. The second one is GPS denied. Cannot find a market for it, and the third one is GPS spoofing, which is actually kind of interesting. This is regulatory compliance in airspace and that kind of stuff. And that one there probably is a market for, and in the military in particular, GPS spoofing is a real thing. When you have active interference, but it's not one I know anything about. So.
And I can neither confirm or deny on that, right?
Exactly.
So, great. Well, I think that's it for today's Q&A session. If you'd like to learn more about robotics, visit udacity.com/robotics. And don't forget to check out our Slack community at robotics.udacity.com. Chris, thank you very much for joining me today. It's been a pleasure.
Thank you.
Take care.